Hey guys, it's Vince. Today I'm covering my M-Shield, and you're probably like, what the hell is M-Shield? Well, a long while ago, a couple years ago, I wanted to bring to market a way to shield cables that are already pre-done assemblies. Typically, my automotive guys love this stuff, and with good reason. It works fantastic. This heat shrink, I don't know if she can see it on camera, is completely lined with the most conductive metal in the world, which is silver. And you can see it right there. And to prove it, very simple, check this out. We're good. So we're fully conductive all the way across. Everything is set. And what I want to show you guys is I get asked all the time, is there a way to shield or double shield cables that are already in an assembly, and that assembly I do not want to install double shielded cable in or single shielded cable? Okay, so for the guys that want to work with single shielded cable, when you buy M-Shield, and this stuff is not cheap, it's not cheap for a reason. Silver is very expensive. This is a 3-to-1 shrink ratio. So when you look at this, this is the maximum shrink. From right here is where it begins to right here is where it ends. And you can see the difference, okay? Now, when you guys want to do an assembly, once again, that does not require you disassembling it, or you do not want to disassemble it, this would be your best friend. And what this kit comes with in the single shielded format, meaning you want to shield a cable just with a single shield, which in this case would be the silver lining within this heat shrink. It comes with a piece of copper 3M tape with a soldered shield ring. This right here is 20 gauge silicone lead, soldered on ring connector, soldered onto the copper tape. You can see 3M. This then would get wrapped around your leads after you remove the backing of the tape. It gets wrapped around your lead and trimmed depending upon however many leads you're doing. And then of course you would just slide this on, and in doing so, sliding it on, the copper is conductive to the silver, and therefore you would have a shielded cable. I can prove that of how this would work. I'm just not going to attach it to the cable yet because we're going to show you a double shielded format. So check this out. If we press here, we push here, now you see how the shield drain works, because the copper is conductive to the silver, in which case you can now ground this. So you're set to go. Of course, we have higher resistance because this is not fully over the cable. I don't have probes in direct placement. It's just making contact. So again, the tighter this gets over the cable, all of that plays a role in resistance as we go. So you'd see a resistance drop. Now, the next question I get, I want to use double shielded cable because I want the best of shielding. I want to be able to filter both high and low frequency electromagnetic interference, and I want to do it without having to disassemble a cable assembly that's already pre-installed in a router I bought from China. And this would be an ideal situation. This is one of my GX16 pre-wired 5-pin connectors. It's a panel mount connector, meaning it's male. This would go inside the rear of your electronics enclosure. This would go over to your drives. Now, many of you see me use this where I put ferrites on here, and you're set to go. Now, some applications you can definitely do that. If I'm doing it myself, it's very easy to do. If you're doing it in your system, you can also do that. There are certain instances where you want to go in a longer distance. Now, when I say a longer distance, this is not to be used. I would not use this past probably maybe 2 feet. That would be the absolute maximum. And the reason I say it, it's not practical. It's very expensive and it's not practical. So for a guy trying to sell it, that shows you how honest I'm being. You've got better solutions that are more practical and giving you the same filtering. But for those guys that are working with a constraint like this, or guys in automotive where there's a cable assembly coming into the vehicle, I get asked this all the time, or motorcycles, and you want to filter it, this is your best friend. And I'm going to show you now exactly what I mean. I'm using here tin braided copper. Tin braided copper typically gives you about an 80% wrap around your leads. And you can see here, as you pull this, it gets tighter. This is fully conductive, and once again, we now have our first layer of shield. Okay, very effective, gives you some spacing when the leads are flexed and bent. Now remember, these are silicone leads in here, and this is one thing that's extremely unique to using this for this application is you can use whatever leads you want. So the more flexible your leads are, the more flexible your cable is going to be. Just keep in mind, be realistic. When this is heat shrunk over this, it's going to compress it. Once it compresses it, you're not going to have that massive amount of flexibility you had to begin with. Once again, it's not usually relative, and it's not usually going to be affecting your application in the sense that typically you'd only use this heat shrink on where you'd have wiring pre-done and you do not want to alter it. So if this was already in an enclosure, I would cut this to length, and everything here is set. The shield drain comes pre-wired, and again, we're just going to build this right now. I'm going to show you exactly how this works. So I've already got the tin braided copper over, and we're just inverting it. Typically, on my double shielded cable, you have the mylar foil internal of the tin braided copper. In this case, we're inverting that. We're putting the tin braided copper first and then going over with the silver lined heat shrink. The principle is the same, and it will do essentially the same thing. So now we've got this over, and I know I get guys that say, well, how do you put the tin braided copper over the leads? It's a very good question. Let me show you. This right here is tin braided copper, and you'll notice when you pull this, just like Chinese handcuffs, it gets real tight. See it? So it constrains, and then you can pull it apart. Okay? Something else you can do. This is a glass stirring rod. You can use whatever you like that's cylindrical. Just insert this inside here, and it opens it up very easy. Once it opens it up, and you want to insert leads, just push. See what I'm doing? Just nice and gentle. And then you just insert leads, and then you do it again. Insert leads, and do it a little again. And then once everything is seated, pull. And pull tight. Now when I say pull tight, you're not going to be pulling at where the leads are attached. You pinch above that and then pinch back here and then pull, so you're not putting any stress on where they're attached to a connector, if they are attached. Either way though, you can see how this works. Very simple. Okay? So now we've got this all isolated, and this is all set. So let's build our assembly right now. Very, very simple. And once again, we use common sense. We want to make sure heat shrink is set on all of our conductors, because naturally we don't want this conductive ground material, the shield, going to make contact with any of these leads. So first and foremost, before you would apply the M shield, you want to make sure that all of your conductors going to your connector are properly insulated with heat shrink. And when I say that, all the way to the base and nice and clean. Once that's done, now, I once again am using a combination of my Omnivice system, and again I'm using my pinch clamp to hold this, and then I can select, and you'll be able to select, what size you would like your shield drain to be. Now you can solder close, you can solder up here if you need more shield drain to actually come over where you're going. This is irrelevant. You just decide where you want to go. I'm going to come up a little more. Now again, my compression over here is actually set in silicone. So I can take this, I'm just going to try to pinch this where I want it. And now I'm going to come over here, iron's going to get hot. I'm going to come up here and we're going to tack this. Now my silicone leads can withstand a lot of heat. Come over here, don't want to get too much solder on here because again, we don't want to worry about melting anything, although like I said, silicone leads, very resilient to heat. This should be very quick and we should be golden. Caster 186 RMA flux, caster number 44 solder available in my store. You guys know that. Most of you know it. Come over here, apply your flux. I'm getting position now, checking where I'm at. Everything is set. Grab my solder. Iron right now, 830 degrees Fahrenheit. Now what I'm going to do is do a very quick touch because this is hot. Done. And you saw how fast that was. Come back over with flux, we got a little bead there. And you can see it's not fully spread, and I wanted it that way. Take a little residual flux. You ever get flux on top of your bottle? Use it. Okay, come in here, same principle. Same process. Done. We'll hit one more time. Kiss it. hit it again. There we go. Done. And that's it. So essentially, we now have our shield drain attached. Once our heat shrink now goes over this, we are now set. We can pinch up, and you can see this is welded on. That's not going anywhere. We don't want to disturb any of our tin-braided copper. Let's keep that nice and tight. Everything here is set. All we're going to do now is insert this right over our leads. Make sure you take your time and don't get the frays, because if you get the frays, you just pull them out like I just did there, and then we just go with it right over. Get your base lined up. You've got enough lead here to do all your connections. And again, this is an estimated length. If you need a little more lead there, this is just demonstration purposes. If you need a little more lead here for conductors to be inserted where you're going, that's fine. Cut this back a little bit. Guys always ask me, how much can be exposed from shielding? Typically, unless a cable is massively exposed, and when I say massively exposed, I would say anything past probably 5 to 6 inches, meaning of usable length, something that you're inserting in a conductor, that would probably be excessive. Keep it within 3 to 5, usually golden. When you go past 5 to 6, that's when you're going to have issues. So right now I'm bottomed out. You can see how the heat shrink is bottomed out on the connector, and we're going to do this very carefully. I'm just going to move this out of the way. Come over here. Invert the connector, because now we're going to use gravity to hold this. Let me get my solder out of the way. One thing about electronics, guys, many of you already know, everything on your desk fights you. So the best thing to do is keep your desk as clean as possible. Got 380 on the heat gun. I'm just going to come in here. We're going to start from the top and work our way down. And you can see exactly what we're getting here. It'll just melt right around, give you a nice base. There we go. Center. Very easy to work with. Precision heat guns are the best to use for this because you're moving down as you go. It's really up to you, but that's really all you got to do. Come over here. If you find your fray is a little out, just go with it. You can see exactly I'm doing a little piece at a time. Now, of course, once you get this started and have a little gap, that's when you can use the big heat gun and come in here and finish this guy off. But for starting out, I always recommend a more controlled method, because we do not want to have this ugly and just messy. I've seen guys do that. You've seen guys do that. You want it clean. Here we go. Once we come over, perfect. Getting enough for our head to come in there, meaning our head of our heat gun, the big guy, and that's it. Keep the gun moving in a rotisserie fashion. That's it. Now we'll come in with our big gun. Finalize this. Start at the top again. You're going a little different heat. I'm doing about 450 right now, and I'm moving tight. We'll come in and just slow. Now you see why I say you really wouldn't want to do more than 2 feet of this. And I have some guys that'll say, I'll do it, I don't care. You can do that. Let me just cool this down a second. Come over here and you can see how tight this got. We got a beautiful assembly here. I'll just keep going. Now I'll grab down here, let it cool. and we'll just keep rotating, but you can see how perfect that assembly is. That's exactly what we want, and that's what many of you would want, and you feel how strong this is. It's ridiculous. Come on an angle, slight angle, wait for that gun to heat, and just keep going. Now you'll notice, like right there as I came up, if I start getting any type of slack and you want it to be straight, you naturally would want to keep this as clean as possible. Drop on. And that is how we build a double shielded cable assembly. So right now, you would skin these off. If this is pre-done, you're all set. You do have some flex. You're not going to get massive amounts of flex because once again, we're compressed. You can see where our shield drain is. Everything here is set. You're all good to go. So we are now all set, and you guys are golden. I'm just bending everything out of the way, and you're good. There you go. And you can see exactly how powerful this really is. Whether you want to do single shielded or when you want to do double shielded. Something else guys have asked me when I'm doing cable assemblies, how do I take out any fingerprints? If you're handling heat shrink when it's hot, you'll notice you'll get fingerprints. Just reheat it. You can use light heat to do that. It'll take out any fingerprints. I mean, right there's some right there, gone. Very easy. Just take your time. Details are everything. Go over slow and steady, and you're in. Perfect. And there you go.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
If an assembly you're doing is bent, or you want to bend it, like right now this is pretty much solid, what would you do? I'm asking you, and I hope you tell me in the comments. The first thing you should always look at doing is relieving tension, and the easiest way to do that with heat shrink is we're going to apply heat to whatever that arc is we want to work with. Now, you've got a couple different ways you can do this. You can use an object to bend over. So if you had a plastic or even a solder spool, you can use this over a solder spool. In this particular instance, just to demonstrate, maybe I'll use my, there you go. Put this here. And now what we're going to do is heat this, and I'll make an arc heating it. Now, of course, whatever you go to heat, you don't want to melt. So do this very carefully. Apply the heat, take it away. Apply the heat, take it away. You'll feel it get soft. Done. And you can see, you can easily form arcs. So it's really just dependent on where you want to go. You want to bend it back. In that case, usually you could just bend it back. But if you're trying to mold it to where it's going to stay, I get my automotive guys asking me that question all the time. How would you work with it if you're going to mold it? That's the best way to do it. And the better the tool is that you're using to formulate your arcs with, the better you're going to get as far as getting in tune with arcing it. But I'm telling you right now, once you get this dialed in, you guys have got an amazing performing unit, because this is absolutely incredible. I want to be very concise on who would use this shielding this way, the way I did it on this 5-pin. Because many of you know the 5th pin on my panel mount connectors is wired with a green lead, and that is typically your ground. However, meaning your ground for your shield. Well, the thing to keep in mind is I'm just doing this for demonstration purposes. And why I'm doing this is to show and illustrate how to use the M shield. In this particular format of how I installed it right here, what you're seeing is if I wanted to shield only from this connector back. That's it. I'm not saying if I plugged a motor cable in here, how would I shield this? Very simple. I mean, if you plug a motor cable in here, your 5th lead is green if you were using a GX16 pre-wired 5-pin as I sell in my store. Then you would just attach your shield drain to the 5th pin, which will come out right here to your ground bus. And this would also go to your ground bus because we shielded this portion. So think about what I just said. The 5th pin would be allocated to the shield drain on your motor cable plugged in. This would go to the ground bus, shielding and dissipating EMI from your motor cable, which is plugged in, that makes contact to the 5th pin. And then this is shielding this portion of the connector back. Do you understand? If you don't, watch the video again, because what I've just explained there allows you to segregate your shielding in the event an assembly is already built and you don't want to mess with this. You've already bought pre-built, let's say, double shielded cables. Some of my pre-built motor cables that are double shielded, they would just plug right in here. They have their shield drain attached to the 5th pin. You would terminate this, go to your ground bus, and then by once again applying the M shield here along with tin braided copper, applying your shield drain, you would then apply this to the ground bus and this to the ground bus. This grounds your motor cable, this grounds this portion of the connector back, and everybody's happy. So again, I hope if you guys have any questions, just ask, but overall, very, very simple once you understand it. If I needed to work with this, I could come in here now with my Nipix. I have enough room, I can do auto strip, boom, and terminate, and you're all set, and now this is a double shielded cable assembly. So think about what you just saw, and think about where you've seen this before, because it's never been done. I know it hasn't. So looking at this gives you 2 options. Single layer shielding, which is typically better for higher frequencies as far as EMI. If you want bulletproof performance, go with the double shield. This is much more difficult in more tight constraints, of course, but when we're talking about bulletproof levels of EMI performance, this is where you're going to be. And you could see just how tight that is using that over the tin braided copper. I mean, you can actually see how the tin is just layered. You get like that snakeskin effect, and that's exactly what you want because it's all compressed, and especially over the shield drain. So when this comes in, it's fully conductive, it grounds out all of that excess energy, electromagnetic interference, and you're golden. Guys, I hope this has answered a lot of your questions about M Shield. Very, very easy to use. If you guys don't understand how to use the copper tape, you can ask me. I mean, I can definitely do another video on that, although I think it's pretty basic. You would either, like I said, you'd cut this to length here, wrap it around your leads, and then just insert, if we're just doing single layer shielding, the M shield over it, and you're done. But for tight constraint assemblies that you do not want to disassemble, best friend. Anything you want to double shield that's tight constraint, if you're patient, if you did want to go over 2 feet, truth be told, you could definitely do that. Is it practical? Is it financially practical? No. Is it practical handling? You just saw what I just did. Does that make sense? You ask yourself. Will it work? Absolutely. But it's a question of, again, where does this fit in your arsenal to get your system stable? Now, I'm talking about CNC robotics. The majority, for my guys in automotive, you already know what you're looking at here. This would save you a boatload of time. If we're worried about any electrical noise in the system, you can do this with motorcycles, you could do it with cars, you could do it with airplanes, real planes, whatever you want to do. Lots of potential, super easy to use, and once again, we want to make sure that whatever project we're doing is stable and is not going to be corrupted by electromagnetic interference. You're all set. Thank you guys for watching.